As you can see, the northern Illinois winter has been upon us. A couple weeks ago, we had a winter storm warning that threatened to knock out our power. Now, thankfully, we had no power outages, but it got me thinking, what if our power went out for an extended period of time? Are we prepared for that? And the answer is no. So I bought a small generator and a few other things and came up with plans to implement a simple, cheap backup power system at my house. Let me show you how I did it.
Okay, before we start, let me just talk to you a little bit about what we're talking about in this video here and what we're not talking about here with regard to backup power options. So one thing I was thinking about when, in terms of backup power, is a whole house system, maybe a solar panel system. When I went to price that out, 10 kilowatts of solar, it's about $14,000 for a full kit, and probably about $5,000 in installation. I'm including installation in this type of scenario because this isn't something I probably can take on, even as an advanced DIYer, just because of the scale of the project plus the permits that would be needed. But this is kind of in range of how much solar power would cost for something for your whole house, and 10 kilowatts is actually fairly small. Similarly, a natural gas generator system, again, this is probably something I wouldn't want to do because of pulling permits and things like that. I'd want a licensed electrician to do this. But, you could see that somewhere in the 10 kilowatt range for a full house natural gas generator backup would cost somewhere in the range of $7,000 to $10,000. What we're talking about here is a very simple and cheap way of taking a portable generator and at least allowing a circuit to switch to it fairly easily for your panel. In my case, I'm mainly concerned about the heat, the furnace circuit. For you, it might be your refrigerator or something like that. But my price range here that I'm getting at is about $600, which includes a portable generator, this is the one I bought, and all the parts to make a quick and easy way to get the power into your house and to have a switchable single circuit. And it's also kind of the range of a stimulus check. Now, I want to give a disclaimer because we're talking about working in an electrical panel, it's high voltage. I'm going to show you how I do it. I'm going to explain how I do it, but you should not do it if you're in any way not sure what you're doing. And so hire a professional to do this work. Also use your judgment and conduct due diligence. I'm going to give you the best that I'm doing, and I'm doing it on my house, and I believe it's safe for me and my family. But you might not use the same products, and the same backup scenarios may not even apply to you. So you may want to change it up a bit, but follow your local code as well, because your electrical code might look different than mine. And also, I might mention products from Generac or Reliance. I'm in no way affiliated with any of these brands. I don't care one way, which product you buy one way or the other. So now that we've got that out of the way, let's get started. The first thing we need to do is determine where we're going to run our portable generator from the outside of our house. I chose this spot on the back side of the house that isn't very visible from the street or our patio. Now see the hole in the very middle of the siding there? That's a little foreshadowing here. I'm filming this a little bit out of order, but that's where I'm going to put the inlet panel, which is going to be an inlet plug that I can easily plug the generator into, and that's what will get the power from the generator inside the house. So from the inside of the house, where that area is this right here in the inside of our staircase on our basement stairs. I'm going to mount this panel right here, and that'll be on the other side of the wall. And so for us to do that, first I'm going to drill a small little 1/4-inch pilot hole with my drill here. And then once I know that that's in the place that I want, I'll do a advanced probing technique known as shoving a screwdriver into the hole just to see if there's wiggling it around, just to see if there's any wiring or anything that might be in the way. And once I saw that was clear, I got my trusty hole hog with a 3/4-inch blade on it, and I just went all the way through both walls, the interior and exterior wall, and I ended up coming through with a 3/4-inch hole. Okay, so for the exterior box, I bought two electrical boxes, but I used the one on the left because it's deeper, and I'm going to need that depth for that inlet. So that's why I selected this one. And whenever you have those exterior grade boxes, they come with those plugs for the extra conduit holes. Make sure you put a little bit of Teflon tape on those, and that'll make them waterproof and sealed up. I'm only going to use the one that's coming out of the back for my conduit. It's going to go straight through the wall. So now here I'm just dry fitting it here. I'm just drawing an outline around it, because what I want it to do, I don't want it to sit on my siding. I want it to be inset into the siding and sit flush onto the house's actual cladding. So I'm just going to take my multi-tool and just carve out that rectangle around the box. And you can see that I'm just carefully carving it out and taking out just the cedar siding, but leaving the actual, not touching the actual wall. Okay, so to prep, I just put like a 12, 14-inch piece of conduit into a fittings and threaded that fitting in. And then I also, because I'm not going to use those tabs to screw it in, I drilled those two holes out, and so I'll just screw it in from the back. So the next one I need to do, now I've got my sheathing all done, is I need to just push it in. And what I'm going to do is from the inside see how much conduit I need to cut off so I can get the conduit cut off perfectly there, and then I'll go ahead and screw it in. Okay, so I marked it right here, right where it came out of the wall, and what I'm going to do is when I put this fitting on here, I'll mark it again where that fitting goes, actually where it sleeves into. Actually, that might be where I want it, about right there. Yeah, so I'll go ahead and cut it there, and I want this to be right there so that this is the threads are coming out of the wall, and then I'll mount this box into there. All right, looks like it fits good. I'm going to go ahead and put a couple 2.5-inch screws in the back of it and screw it in, and then we'll go put the box on the other side. All right, now we have our box screwed in and our conduit ring on here, so you can see right through to the outside. All right, well, here's my rigged up thing. I'll show some more details on how I did this. I don't know what the best way to do this. There's likely a plate that you could put here. That would probably be a better way to do this, where you can mount your inlet to. This worked out though fine though, mounting the inlet to the actual back of the our outlet cover here. So I mounted to the back. I used these things here, these little wings that would normally be used to mount that box. And then I went ahead and wired it up. So I put some 12 gauge wire. I'm not gonna put any more than 20 amps through this thing, even though the generator is capable of 27. I'm only gonna do 20. So this is just 20 amp wiring. Put a spade terminal on, where is that? On the green wire, because all I'm going to be doing is just attaching the green wire to that screw there, and then from there the ground is the conduit, all metal conduit. All right, and there it is. I don't like how it sticks out that far, but I needed that extra deep box to make sure I had room for that inlet. If it was an outlet, I wouldn't have to have that kind of room. So I just found some long screws here to attach it in. I didn't go too hard on these. You only want to tighten them to where this foam is sealing really well, but you don't want to, like, rip it apart, rip the plastic apart. So that's all in there. Everything's nice and solid. I like it. Nice. All right, let's go do the inside now. I think we're done with the outside. As far as finishing this, it's too cold to caulk right now, so I think it'll be fine. I mean, this is plenty far off the ground. I made sure it was way up there, close to 3 feet off the ground. So I'll go ahead and caulk and repaint and fix this up when it gets a little bit warmer, probably in a couple weeks. All right, so the inside outlet is wired up, and I just did the wired it to here, and I will screw that into the box. I also knocked out this knockout here, so that'll be going to conduit that's going to go along the wall and to the panel.
and we'll talk about that in a moment. But for now, I'm going to get this thing, what I'm going to do to test it is I'm going to run an extension cord from a working outlet to the outside inlet, plug it in, and then just put a tester on here just to make sure I got everything right. Okay, so I got this thing plugged in as a test. So it's plugged into another working outdoor outlet that I have around the corner. So let's go see if I wired it correctly on the inside. Awesome, so those two lights mean that I have a closed ground and I have my hot and neutral in the correct location. So we are now that we have this outlet, that just means that we now have the ability to wire in our generator from the outside and have it energize this outlet here. So the next step is we're going to run a circuit out of there. I already got the knockout there. We're gonna continue that circuit over to the panel, and we're gonna wire up our furnace breaker switch. Okay, well, we're at our breaker box now, and I've got this little piece of equipment right here, and I'll give you the details about that. But this is the furnace transfer switch, and it's a single circuit transfer switch, and it's manual, right? So what that means is our furnace is going to have a hot wire, since it's just 110 volt. It's a gas furnace, but the 110 is just to run the fan and the board. So the hot wire is coming in into the panel. What we're going to do is take that hot wire and we're going to split it. So that hot wire is going to be split between the line, which is going to be from our breaker, is going to go into this line here, and then the generator is the hot from the generator. So this allows you to switch your furnace wiring between coming from the line, or your power voltage, or from the generator. So when the power goes off, what you'll do is I'll simply plug in the generator, start it up. Once that's going, I'll flip this switch to generator, and then my furnace will be powered up, right? So what I need to do is figure out where I want to mount this. I can mount it like here and have the wiring going in there, or on this side if that makes more sense. I have a little more room over here, so maybe I'll do that. So I'm going to go ahead and take the cover off here and be real careful, because again, we've got two hot legs, 240 volts coming into here, and a lot of current, 200 amps potential current. So we got to be very careful being in this electrical panel here. But I'm going to go ahead and take that face off and see if we can go ahead and wire in this furnace circuit. Okay, as you can see, I ran these wires all the way back through, and I'll show you the other end of it, which is going to be attached to the outlet, which is attached to the inlet. So these two wires run all the way through. I did not run the ground because everything is steel conduit, so the conduit itself is the ground. So we've got just our hot and our neutral. Here's the back of the unit. So I don't know if I mentioned this, but we've got the switch and the little breaker. We've got this little plate here. Whoops. So this plate is where you can mount that inlet to, but obviously I didn't do that. I mounted it to the outside of my house so I could plug the generator into it. So the plate stays there. Now, if you did mount that, you would use the black wire. Sorry, I'm not in scope. The black wire that's loose here, the green wire, this one right here, which would be your ground. I don't need that because everything's going to be grounded to the box. And then this white wire. So you've got a black, these are just loose in the box. So these are what I'm going to tie to my black and white as if it were the inlet right there. Okay, I carefully wired, or I got the pigtail on. I've got all the wires run carefully around here, making sure not to touch the wrong stuff. So now we have our red wire. I took the breaker out right here. So that's where my furnace was. Here's the breaker. So the red wire, this is the red wire that's coming off that pigtail. Remember, that goes to our switch. And here's the black wire that went to our furnace that was going into the breaker. Now instead of going into the breaker, we're simply going to tie it to the red wire. And we're going to wire nut it. I might also put some tape on it as well. Always use these good, high quality winged wire nuts. Okay, so that's wire nutted on there, and we'll tuck that in there. Now, the black wire, need to strip a little bit of it. The black wire is going to go to the power, which is going to go to the breaker. So let me strip this. Okay. And then we're going to put the black wire into the breaker. Remember, black wire goes on the line. Open that up a little bit more. Okay. Using my 1000-volt screwdriver here. I'm just being real careful wherever I put my hand. I need to know where that is. Okay. So now our breaker can get replaced. And what that's going to do is it's going to power. There we go. Okay, that's back on. Okay, so we got our black wire to our breaker, the black wire from here. We got a red wire from here that's just tied into the old, the furnace circuit. Well, not the old one, but the furnace circuit. And now we have two more wires left. We have a white, a neutral, and we have a ground. So both of these we can go ahead and just tie to the neutral or the ground bar here. So I'm going to go ahead and just strip them and just tie them into screw them into the ground bar. Okay, I got the panel all buttoned back up. Everything looks good. Everything's buttoned up. What I didn't show you is I ran all new conduit here. Obviously, you're going to run Romex or whatever it is, and I didn't show that part because that's just unique to my installation. You know, the type of wiring I need to do, and so it goes all the way back. And here is where we tie in to our outlet here, which I'll mark this clearly as a generator outlet only, and put some covers on it. But then obviously it's tied into the inlet, which is going to go to our generator outside. And so for those commenters who say that I shouldn't do my own work, let the pros do it. Here's my conduit, level, anchored against the stud, and here's from a previous professional, flapping in the wind. Okay, all the wiring is buttoned up. I'm going to go ahead and I don't have time to test the generator tonight, so I'll wait for that tomorrow. But what I'm going to do is I'm going to put my circuit tester on and you can see it is completely dead, the furnace is. And then I'm going to turn the switch I'm going to turn the furnace breaker on. Done with that. And then this, let's see, just make sure. Okay, breaker, still dead. Now, we're going to turn this to line. And that should energize the furnace. And there we have it. And we have our two orange dots. That means we've got the proper circuit. And the furnace is ready to go again. So the only thing I have left to do tomorrow is test out the whole generator feed. Now, I'm not going to turn off my whole power to my house, but what I'll probably do is plug in the generator into that isolated circuit and then just flip this to generator, and that should allow the furnace to maintain its voltage and still run. And that'll be the test, and we'll wrap it up. Well, today I was going to go test the generator, and now I'm thinking I won't, because I have to drag it all the way over to the side of the house over there. There's still a lot of snow. It's -1 degrees out today. I don't feel like messing with this. Also, I'm a software developer, and there's two types of tests we do in software: unit test and end-to-end tests. And I feel like we did a pretty good job of unit testing everything yesterday. We know that each branch of the circuit is wired correctly, and we also know that I off camera I tested that switch on the generator transfer. That generator, my mouth is so frozen I can't talk. The generator transfer switch, I also tested that as well. I know that works with a no meter. So I'm comfortable with saying, you know, I don't really need to test it right now until I actually need to, or until the summer, where I intend to give it a good thorough testing. But here's the generator. It's a Generac GP3300. It costs about $400, and it can put out, it says 3,300 running watts or 3,750 starting watts. This is enough to run, you know, about not quite 30 amps. But like I said, I'm only going to go off of one of the 20 amp outlets on it, and that's all I plan on doing, really. It does have an output for this type of connector, as well as the standard NEMA 520 connector. It says it has a 30 amp RV hookup, but really all it is a pigtail off of that twist lock connector. So it's, you know, but yeah, I think it's going to be a good unit. I don't know. It's still in the box. I haven't used it yet, but we'll see. Well, that's a wrap. I feel a lot more prepared now for in the event of a power outage, and I hope I've at least given you some ideas on how you can be more prepared too. Thanks so much for watching. Please like, share, and subscribe.